Hello students, hope I'm getting you all well. This particular section we are going to discuss about a special case of refraction. What is that? Total internal reflection. We are already aware now what is that refraction of light, what are the various laws of refraction, that Snell's law, refractive index, absolute refractive index. Now the special case, the total internal reflection, but then what is the must condition for this particular total internal reflection to take place? The condition is the ray of light should travel from denser to a rarer medium. What is the must condition? The ray of light should go from denser to a particular rarer medium. Then only this particular phenomena, the total internal reflection, can take place, such that what is written further, that in that case, no, if that angle of incidence when it is going from denser to rarer, then only it can take place. And then if that angle of incidence is greater than that critical angle, so as to understand this concept of total internal reflection, no, first we need to understand what is this critical angle. Correct, no? Such that if that angle of incidence is greater than that critical angle, then only this phenomena of total internal reflection is to take place. So first let us understand what is this particular angle that is known as critical angle. Correct, no? So as to understand this critical angle, no, what was the condition, the must condition for TIR? TIR in short, total internal reflection, no, in short it is termed as TIR. Correct, no? Here the must condition, the ray of light should go from denser to a rarer medium. First case, here you can see a normal incidence. If the angle of incidence, it is equals to what? 0 degree. What is that angle of refraction? It is also equal to 0. Correct, no? The first condition, if the angle of incidence goes to what? 0 degree. Angle of refraction, it is also equal to what? 0. But such that if that there will be a certain value of angle of incidence, no, here you can see. If there will be a certain value of angle of incidence, whenever the ray of light that is going from denser to a rarer medium, no, it will bend towards or it will bend away. So in this case, the ray will bend away from the normal. Correct, no? The ray will bend away from the normal, such that whenever it is going from denser to rarer, no, if I will increase that angle of incidence, if I will continuously increase that angle of incidence, what will happen with that angle of refraction? Angle of refraction will also increase. If I will increase that angle of incidence, angle of refraction will also increase, such that there will be a certain angle of incidence. There will be a certain value of angle of incidence at which the angle of refraction became 90 degree. Yes, there will be a certain value of angle of incidence at which the angle of refraction became 90 degree. This particular angle of incidence, this particular value of angle of incidence, that is termed as what? Critical angle. Getting the point? So whenever the value of angle of incidence at which the angle of refraction became 90 degree, this particular value of angle of incidence, that is termed as what? Critical angle. And it is represented by IC. I in the subscript C it is written, and that is actually what that symbol, so as to represent that critical angle. The angle of incidence at which the angle of refraction becomes 90 degree, and that is only possible when the ray of light is going from denser to rarer medium. Clear with the things? Such that now if I will further increase that angle of incidence, I was increasing that angle of incidence continuously, no? I got this particular value of angle of incidence at which that angle of refraction became 90 degree. If I will further increase that angle of incidence, what will take place? Now, in this case, the total internal reflection will take place. Now, the ray will not go into that rarer medium. If that angle of incidence is greater than that critical angle, no? If it is greater than that critical angle, now the ray will not go into that rarer medium. Instead, it will bounce back. It will bounce back into that same denser medium, and then this particular phenomena, it is termed as what? The total internal reflection, such that here you can see the must condition is the angle of incidence should be what? Greater. Angle of incidence should be what? Greater than that critical angle. In that case, that TIR will take place, and then after that, no, it will start to follow that simple laws of reflection. It will start to follow that simple laws of reflection. Here, this angle of incidence will be equal to that angle of reflection. Understood the point? This is what that very interesting, the total internal reflection, a special case of refraction, whenever a ray of light is going from denser to a rarer medium, and if that angle of incidence, here you can see, if that angle of incidence is greater than, if the angle of incidence is greater than that critical angle, the ray will not go into that rarer medium, instead it will bounce back. It will bounce back into that same denser medium. This particular phenomena is termed as what? The total internal reflection. But the thing is that, why this name that is given total? Why the name that is given total? They could have said like the internal reflection. Why the name that is given total? Now listen very carefully. The thing that we have discussed in the very beginning, what is that? Whenever a ray of light is going from one medium to another, three things can take place. First thing is what? Refraction, bending, no? When it is going from one medium to refraction, reflection, and third thing is what? Absorption. Correct, no? Absorption, three things may take place, correct, no? So here is the thing, here the same thing that we can see, a ray of light that was coming, no, it is bending away, it is going to the rarer medium, fine. So in this case, the refraction, reflection as well as absorption, all the three things are taking place, and which this red colored ray of light that we can see, no, it is termed as that partially reflected ray. What is that? Partially reflected ray, such that from that same source of light, if I will actually take another incident ray whose angle of incidence is what? Greater. Whose angle of incidence is what? Greater. In that case also, that partial refraction is taking place. What I am doing, I am continuously increasing that angle of incidence. I am continuously increasing that angle of incidence such that on further increasing that angle of incidence, no, but I will find that angle of refraction will further increase. The angle of refraction will further increase such that that value of angle of refraction became 90 degree, and this value of angle of incidence, no, that is termed as what? Critical angle. That is termed as what? Critical angle. And then now after this, if that angle of incidence is greater, if that angle of incidence is greater than that critical angle, no, now no refraction, no absorption. Yes, absorption of light even don't used to take place. If that TIR, the total internal reflection that is taking place, no, entirely, the ray of light that was coming from the denser medium, no, it completely used to bounce back into that denser medium. There is no loss of intensity. No loss of intensity of light that used to take place at the surface that is separating the two medium for that same sake. This particular type of phenomena, it is termed as what? Total internal reflection. Because in the previous cases, no, in the previous cases, what was taking place? In the previous cases, only that partially reflected ray I was getting, and always there was some sort of absorption that was taking place. But in this case, there is no absorption of light used to take place entirely. The ray of light used to bounce back into that same denser medium. This phenomena is termed as what? The total internal reflection. Clear with the things? Now here, can we find this value of critical angle? Can we find this value of critical angle for a particular pair of medium? Yes, there is a method. What we need to do? We need to apply that Snell's law at the time of the critical angle. At the time of this critical angle, that means when that angle of incidence, it is equals to what? Critical angle. No, here you can see when the angle of incidence is equals to what? Equal to the critical angle of refraction became 90 degree. So in this case, we can apply that Snell's law so as to obtain the value of critical angle. Okay, Snell's law, what that Snell's law used to say, that the refractive index of the medium in which the ray is going with respect to from where it is going, it is equals to sin I upon sin R. Here the ray of light is going into the rarer medium with respect to the denser, from where it is going denser. So the refractive index of rarer with respect to denser, refractive index of rarer with respect to denser medium, that will be equal to sin I upon sin R. Angle of incidence over here is what? IC, correct, no? Sin IC upon sin 90, what is the value of a sin 90? We already know 1, correct, no? So that means this critical angle we are finding in a certain particular formula, refractive index of rarer with respect to denser. But listen, whenever we will see that questions, no, those are based upon this total internal reflection, they will never give us this. They will never give us the refractive index of air with respect to glass. They will always give the refractive index of glass with respect to air, or the refractive index of water with respect to air. That means they will, in every question, no, we will always find the refractive index of a denser medium. Refractive index of a denser medium with respect to rarer one. So that means if I will convert this particular formula in terms of the refractive index of denser with respect to rarer, no, then that particular case, this particular formula, no, it will become more useful for me. And then that is very convenient. We know the refractive index of rarer with respect to denser, it is the reciprocal of refractive index of denser with respect to rarer. Correct, no? So on doing that reciprocal, no, the refractive index of rarer with respect to the reciprocal of that is what? The refractive index of denser with respect to rarer, and from there, what will be the value of that critical angle will come out? Critical angle will come out as sin IC will be equal to 1 upon the refractive index of denser with respect to rarer. Straight away from here I can get the sin IC, it is equals to 1 upon the refractive index of denser with respect to rarer. That means if I know the refractive index of denser medium with respect to rarer, straight away I can obtain the value of critical angle from this particular formula. Utilizing that Snell's law, such conveniently we have obtained. Correct, no? Sin IC, it is coming out, it is equals to 1 upon refractive index of denser with respect to rarer. Some questions, no, this will be useful, we'll see. This phenomena of total internal reflection in nature also we used to see. This particular phenomena in a particular case, this particular phenomena is termed as the mirage formation. This is also based upon the total internal reflection, that mirage formation. What used to take place? Now listen, you must have experienced this thing. Onto those summer afternoons, no, let's say we are moving onto a highway with a certain particular vehicle. Let's say a car we are in and we are moving onto a highway. What it is to appear that far away onto the road some water is spilt. And then as soon as we used to reach over there, again that no water is available over here. Again it appears the water is present ahead. It is ahead present, correct, no? Again we are reaching, again that water is not available. This particular phenomena in Hindi it is termed as what? Mrigtrashna. Here it is termed as what? That mirage formation. And then behind that mirage formation, no, this is the total internal reflection that is responsible. Now, this phenomena, mirage formation, that used to take place whenever it is actually what? Summer afternoon. And that summer afternoon, no, the land used to become very hot. And that air that is present above the land, no, that is also very hot. As compared to the air that is present at the height. So that means air that is present at a comparatively height, no, it is actually what? Denser. As well as it is also optically denser. The air which is present up, it is a denser one, and the air that is present below, close to the land, no, it is actually what? The rarer medium, because it is a hotter one. It is actually what? That hotter air, and hotter air is actually what? Optically rarer also. Now listen very carefully. When the ray of light that is coming from the denser and it is going towards after reflection, when that ray of light is going towards that rarer medium, the upper one, denser. Lower one is actually what? That rarer medium. We know that TIR used to take place when the ray of light is coming from denser to rarer. Ray of light coming, and when after reflection it is going towards that rarer medium, what we know? Whenever the ray of light is going from denser to rarer, it used to bend away from the normal. Again, it used to bend away from the normal, such that here at this particular point, you know what has taken place? Here that angle of incidence was greater than that critical angle, such that what has taken place? That total internal reflection. So instead of going in the downward direction, that the same ray that was coming from that particular object, no, after undergoing that total internal reflection, those rays reached to the eye of that particular observer, and then to that particular observer it appeared as if those rays are coming from some down location. And then it appeared as if some water is spilt. And that image of that particular object is actually what we are seeing. Correct, no? This is that phenomena, that mirage formation. Mirage formation is completely based upon that total internal reflection. So in this case, what was taking place? The ray of light, when it was going from a denser to a rarer medium, and if that angle of incidence was greater than that critical angle, angle of incidence was what? Greater than that critical angle. In that case, the ray bounced back into that same denser medium from where it was coming. Phenomena is termed as what? Total internal reflection, based upon which mirage formation is there. Here you can see, okay, straight away some question that is coming based upon this total internal reflection. Let us check with the question. What is there? A disc is placed onto the surface of a pond. A pond is there, water is filled in that. The pond is there, a disc is there. Disc is held onto the surface, floating. Pond which has a refractive index 4/3. Water which is present inside the pond, no, they are talking about the refractive index of water that is present inside. 5/3 is that refractive index, correct? A source of light is placed 4 meter below the surface of the liquid. Okay, the case is like this. A pond is there, a source of light. A source of light is held at a distance of 4. This is that source of light, correct? No, this is a particular source of light which is held at a distance of 4 meter. That means depth of this particular pond is given 4 meter, correct? Below the surface of liquid. The minimum radius of the disc, the question is coming now. Minimum radius of the disc so that the light is not coming out. Absolutely, okay, this from the source. This is that source of light. Let me write down this as S is the source of light. From the source of light, the light should not come out. Should not come outside this particular pond, no. What is that must condition? What is this value of this radius of this particular disc? Okay, what should be the value of the radius of the disc so that absolutely the light ray should not come out? Now listen, so as to understand this, no, this question, what they are asking, how we are going to obtain the value of this radius of this particular disc. Let me first tell you. The light rays, those are coming. The light rays, those are coming from the source. And if those light rays are actually going normal incidence, if that angle of incidence is equal to what? 0 degree. What will happen? Angle of refraction is also going to remain 0 degree. Correct? No? So there will be no bending of light will take place if this disc is not there. If disc is not there, in that case that ray of light will go straight. Such that if those rays, those are going like this side, if that larger is that angle of incidence, larger is that angle of refraction. If I am continuously talking about those rays, those are actually going far. In that case, the angle of incidence will be large and the angle of refraction will also be the large, such that here this is a certain particular ray that is going at an angle of incidence that is equal to the critical angle. In this case, what will be the angle of refraction? What will be the angle of refraction? Angle of refraction became 90 degree. So is in this particular case the ray will not come out. The ray will not come out. That means I need to find this value of r, this particular distance. This particular distance is the distance I will find, and that is actually what the value of the radius of this particular disc that is kept exactly above this particular source of light, such that the ray of light is not coming out. How we can find? For that again I need to apply that concept, that Snell's law. I need to again apply that Snell's law. Snell's law in that particular condition, such that what is this? This is a falling, that is this particular ray that is a falling at an angle of incidence that is equal to that critical angle. And then this side also, can you see? These are actually what? Alternate interior angles. So what is this? Critical angle. This angle is also that the same. Such that what is that angle of refraction? Angle of refraction is equal to what? 90 degree. Angle of refraction is equal to what? 90 degree. Let us apply that Snell's law. What should be the value of r they are asking now? Let us apply that Snell's law. By Snell's law, what we know? Snell's law, what we know? That this refractive index of rarer with respect to denser, it is equals to sine IC upon sine 90. Sine 90 it is equals to 1, that we know. So from here, what is that critical angle? Critical angle, sine IC. Sine IC, that is a formula that we have directly studied. No, 1 upon the refractive index of denser with respect to rarer, and then the refractive index of denser with respect to rarer, that is already given into the question. What is that refractive index of water which is filled into the pond? 5/3. Let us substitute that value. Substituting the value, that sine IC, it is equals to 1 upon 5/3. So reciprocal, it will go up, it will become 3 upon 5. Correct? No, this is the value of sine IC that is coming. Correct? No? And then what we know is sine theta. What is that? A trigonometric ratio. It is the ratio of perpendicular upon hypotenuse. It is the ratio of perpendicular upon hypotenuse. Okay, fine. So if that perpendicular and the hypotenuse is given to me, no, let me also find that let me also find that base. Straight away, if it is perpendicular that is already given, let me also find that base first and foremost. What is the base coming? By Pythagoras theorem, what we can see? By Pythagoras theorem. By Pythagoras theorem, what I am finding, this base will come out as equals to square root of hypotenuse square minus perpendicular square. What is that hypotenuse? 5. 5 5 is 25 minus 9. Correct? You know? 25 minus 9 is 16. Square root of 16, it is equals to what? 4. So from here the base is coming out as 4. 4, and then carefully examining this particular diagram, what we are seeing, that here, what is that base angle? In this particular triangle, here you can see, if I am marking this triangle as P, Q and R. In this particular triangle P, Q and R, what I can see, what is that base angle? Base angle is IC. From here, what is the value of base? That same value it is coming, and then this is that this particular is actually what, that perpendicular. So from where straight away we were getting the value of perpendicular as 3. So straight away the value of R is directly coming out. So base was what? 4 meter. And from here, what is that perpendicular that we have already obtained? What was that value? This value was what? 3. So straight away the value of a radius will be equal to, radius R will be equal to 3 meter, such that the ray of light will not come out. So some options are given. Let us check with those. So here directly the option, it is what? B must be what? That correct option. 3 meter must be what? That correct option. B is that one. So here this is how we have applied the concept of total internal reflection, such that a very convenient formula. What was that? Sine IC, it is always equal to 1 upon refractive index of denser with respect to rarer. That is always directly going to help. Clear with the things? Such interesting is this particular phenomena, total internal reflection.